Our AI chatbot is stuck in a box. It's got a tool, but it's not in contact with the outside world, apart from the OpenAI API, which we hooked it up to. So it's basically just ChatGPT with an extra tool that tells the time. Today, we're going to hook it up to Brave via an MCP server. So we're going to make an MCP tool call. We're going to implement our own transport so that we can contact the MCP server that we're running locally with Docker, and we'll get the results of a web search back in our chat. If you're following along, you'll need a Brave API key. You can get that from the link in the GitHub, which I'll link in the description. They do have a free plan, which you can use for this. You might need to register and register a card, but apart from that, it's going to be free. They're not going to charge you unless you go over the limits and do a lot of web searches. Once you've got that, put it in your .env file, which we fixed up last time, and you can continue with the tutorial. Just going to wire up the streaming API of Rig, which we didn't do last time, although we did allude to it, so that we can get the results back in a stream rather than in one big chunk. Because now that we're going to have bigger responses, rather than just the time, it's going to make sense to have it streaming in the chat. Luckily, Rig has an API for that, so we'll just hook into that and we'll get the results back just as before. We're going to start off where we left off last time with a simple tool that was telling us the time. We were using the prompt API of Rig. We're going to move over to the stream API now, which is what you'd be used to if you were using a chat. Usually it would stream the response and you would see it building in the UI in front of you. We already set up the handlers on the front end to deal with this, so we're actually just going to update the back end and we should be good to go with the streaming. First of all, because actually in between the time of these videos, we did get a new release from the Rig team, from Josh, who's the head maintainer there. So we have got a slightly different API. We're just going to update the version in our cargo manifest. You can see I've got this extension which is telling me that there's already an update, but we also actually need some features for the MCP. So we'll add that. And we're going to add a utility library called futuresutil, which is going to help us to process the response of the streaming from the LLM. Now that we've got that, we should be able to make our changes in source lib. So this is where we left off last time. We changed it a little bit so that we were actually logging out the errors instead of doing print line. If we want to access them in the console, like I showed you last time, we need to use the logging for that. But apart from that, it's pretty much the same. We're going to use stream extension from the futuresutil crate, which is just going to help us to process the results of the call to the streaming API. From the Rig crate, we're going to need streaming prompt. So we'll add that here. And we're also going to need another aspect of the new streaming API, which just came out in 0.19, which is going to use a multi-turn stream item. So it's going to pretty much keep streaming until you get an end result to your stream. So the main change we're going to do is we're going to change away now from using the prompt method on agent, and we're actually going to use stream prompt. You see autocomplete's already helping me to fill that in. We're just going to pass the message as we did before. So we've got some compiler errors already, and that's because stream prompt is not going to return the same thing. We can see here it's going to return a streaming prompt request. We're actually going to use the futuresutil library to iterate over these. So if we actually take this and put it into a variable, that's going to need to be mutable. Then we're going to put a while-let loop here, because this isn't just a one-off operation, this is going to be continual. So we're going to create a while-let, some chunk is stream.next, and the next method is going to come from the futuresutil extension trait. So we'll just put that in here instead. And then we're going to match on the response. So we can get rid of this. We need to end our while-let block here. So we updated our branches of our match, but we're actually still matching on the wrong thing because we have the old logic here. So we actually just want to match on the chunk that is returned from stream.next. And now you can see it's compiling okay. So If we get text, then we send that as a delta, we emit the event. If we don't get that, the stream is complete and we can break or handle the final response. We're not going to do anything for now, and we keep our old error type. And then we just need to update the return type because we don't have a result anymore, and we'll just return this unit struct, which is what it's expecting. If we look at the app, and then if we run ask time this time, you'll see it's more or less the same, but it's going to stream the response. It happens quite quickly because there's not much text to come through. If you watch it, it's actually going to stream the text as it comes through. It was pretty quick, but that's what it was doing. We may as well change our user interface. We actually had some buttons that we'd set up in the UI before in our app.tsx. We're going to change these because we actually want to search the web. This is going to be the key to activate our web searching tool on the MCP server. We're also going to change the input text. We'll just take this suggestion from Copilot for now. For the last button, we're actually going to change it to list tool. So we're going to just say, what tools do you have available? There you see it's updated. This is another good thing about having a web server that works in dev that is streaming to your mobile, is that you actually have a kind of hot module reload working all the time as well, which is pretty cool. If you're enjoying this content, please give me a like and a subscribe, because it is a new channel and I would love to reach some more people. The more I can get this out to people, the more collaborations we can do, and the more ideas I can get for what to build using these cool tools. Let's have a quick look at the documentation about how to use MCP clients with Rig. It tells you to add MCP core. Now, this might be a little bit out of date. They just updated the API, but I couldn't get this to work. I had to use RMCP, which is a different crate for the MCP part. But I did have to do this, add Rig core with the feature flag. And then I manually added RMCP with these feature flags here because we have to use our own HTTP transport in order to do this. We're on Android, so we can't use standard I/O, just meaning we can't use the normal terminal to interact with it. If it was a local process, we could do that. But actually, as far as Android is concerned, it's not a local process, so we're going to want to do that over HTTP. And request is just to do the HTTP requests. There's some issue with RMCP version 0.5 where it's not including this properly. I think they fixed it later, but for now, we need to use this. We can see here on the GitHub for Brave that it gives you all the information you might need. Tools, we're going to use Brave Web Search, although if we list tools, we'll see the rest of them. There's other ones you can use, video or image, news, etc. The important thing for you is make sure you have your Brave API key. We're also going to set the Brave MCP transport when we set this up. Just make sure you have your API key in your .env. And then what we're going to do is we are actually just going to run it. We just use Docker, and I'm just going to use this command I already used. You can see my API key. I'm going to change that soon. Docker run, and Brave MCP transport is HTTP. We have to set because we're not going to use standard I/O. If you're running it on a normal process on your local host, you could do that. And we set the API key, and we set a port that we want to communicate with the MCP server with. That's just the name of the image. It will pull it if you don't have it already. I already had it, and it's going to run on here. So this is what we need to connect to with our agent streaming. So this is the change that we need to make. It took me a little while to figure this out actually, because it didn't work exactly the way the API said it would. First of all, we're going to rename to stream message because it fits better with the streaming API. This is how we're going to change the calling of our tool. So we need to connect to the MCP server that we've set up with Docker running on our localhost PC, not our Android device. In order to do that, we are going to create the agent, and then we're going to add tools. If you look in the documentation again, this is the way you add tools. So you get the tools that the agent builder already has, you make an iterator, and then you fold in your new tools from the MCP server. So if we go back to our IDE, you'll see we're doing something similar. So we create the agent, and we assign it to a mutable variable. We've given it a preamble, telling it it's got access to the tools. So this is what's going to make the LLM look for the tool that you've given it. Then we're going to get a connection to our MCP server, which we'll do in a second. This is just a sanity check so that we can see what tools we have in the logs. And then for each of the tools, we're going to call agent RMCP tool, which is going to add it to the list of tools that the agent has available. And then we're going to build the agent. So looks a little bit different from what we had, but it's just following the docs. This bit was pretty easy. In terms of getting the connection, this was a little bit more complicated. Thankfully, we're in Rust, so we can actually do systems programming and just sort it out when something goes wrong. The logic behind this is that we need to create a connection that is persistent to the MCP server. So I'll just briefly explain what's going on. You can copy the code if you just want it to work, but we need a connection pool. And in order to do that, we've actually created this static thing with a horrific type signature here. You can just think of this as like a magic static variable that will let you access something across threads, and it's a once cell, meaning it's a singleton, it only happens once, right? So you want one of those. This is how we're getting the connection. We have to create the connection as well, but this is how we're storing and accessing the connection. So we've called this a connection holder. It's going to create the connection, it's going to get the tools from it, and that's what it's going to return with a client so that we can send messages. And that's how we added the tools to the client. Okay, so that's getting the connection. I know it's a bit complex, but if you want to get more into async Rust, just let me know. We can go into that. It's really enjoyable once you get a hang of it. How do we create the connection? Well, this is where we need to know a little bit about how clients communicate with MCP servers. We actually have to use the URL that we got, which is our localhost 8080. We need to add the MCP part to the string. That's what this format's doing. But we also, because we're going to be accessing this from Android, we need to get it to contact our localhost, which was streaming the web server. So this is the IP of our localhost. We need to replace that so Android can find the MCP server. And then we need to create a transport. Now, there are different ways that you can communicate with the MCP server. As I said, one of them is standard in-out, which is like your console input and output. But we actually need to use HTTP. There's a method called server sent events that's used with MCP servers, including this one. And we set up the Docker image to be using this. So this is where the RMCP crate comes in, create a transport. This is the client info that you saw in the docs. We're going to serve the client info over the transport, and we're going to get a client, and we're going to get some tools, which is listing tools from the client. Then we're going to get the tools, and we're going to create a schema, and this is going to be used by the LLM to define what tools are actually available. And we're going to return them so that we have the client and the tools, and this just makes sure that the service doesn't get dropped. So we're going to start the app from fresh. We have our log down here. So that's ADB logcat, the same as I showed in the last video. You can see it's actually connected. Before, I had this working and it's telling us we have tools, but let's run it fresh and we'll get new logs. So we'll run pnpn run tari android dev. Now if we go over to our phone where it has reloaded, the difference will be when we list tools, it's going to have more than one tool. So now we've listed tools. And there we go, saying we have a web search, a local search, video search. These are all the tools that were listed on the Brave MCP server. So now the last thing to do is just search the web and see if it comes back with results. So there we're searching the web and it's thinking, and hopefully it's going to contact the MCP server. MCP server is going to do its Brave API calls with our Brave API key. And there you go. Something about Trump imposing a fee. I don't know, it's streaming, I can't really keep up with the news right now in multiple ways, but here we go. It worked, so we're satisfied. It seems to have done it twice, or it re-rendered twice, but we got the data, that's what we care about. I'll see you in the next video. Let's recap what we've done today. We hooked our app up to the streaming API of Rig so that we can get a better UX. We ran a local MCP server for Brave search. We got our API key, we put that in, and then we used the Rig API for MCP servers with a little bit of extra Rust systems programming to get the transport layer working properly. And we were able to get a MCP tool call to get some web search results in our chatbot. Now you can apply this to all sorts of different external APIs. This was just the easiest one that I decided to choose. We used the Brave Search MCP server because it's pretty easy to run locally, and then we could just very quickly get our app going. If you're interested in some others that you could be using, please check out my article in the description below, where I list 8 cool MCP servers that you could be using for your business workflows today to improve efficiency and just do cool things a bit quicker.